In this episode, we're going to troubleshoot an enterprise network. I'll show you how to do it, and we'll talk about some concepts along the way. We're going to use a variety of technologies that we've encountered, including IPv4 routing, IPv6 routing, port security, EtherChannel, DHCP, and NAT. Our task is to review the requirements, isolate and resolve any problems, and then document the steps we took to verify the requirements. The company replaced routers to accommodate a fiber connection between locations. Configurations from the previous routers with serial connections were modified and applied as the starting configuration. IPv6 is being tested on a small portion of the network and needs to be verified. We'll be discussing verifying switching technologies, verifying DHCP, verifying routing, and finally verifying connectivity. Greetings to my tech heads out there in the KevTechify Nation. And if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. Kevin here at KevTechify. Let's get this adventure started. Packet Tracer Lab 12.5.13 Troubleshoot Enterprise Networks. On the left side, I have the packet tracer opened up. This shows us our topology. We'll interact with all of our devices. On the right side, I have our instructions. The way bottom right is the actual packet tracer activity window that opens up when I open up the packet tracer file, and that includes all the instructions. In the upper right, the majority of the right, that is a Word document that has all of those packet tracer instructions from the original window, but in the Word document. Why do I have that? There's a bunch of questions we have to go through and answer. Word document will allow me to save my answers. In this lab, what we're going to do is we're going to verify some switching technologies, DHCP, routing, WAN technologies, connectivity. Basically, we're going to look at our entire network, make sure it all works, and how is it working. Here's an addressing table with all of our devices on our network, with all of their IP addresses, how the devices are configured, and down to our instructions. Part 1, verify switching technologies. Port security is configured to only allow PC1 to access switch 1's F03 interface. All violations should disable the interface. We are looking at PC1, which is right here, connected into switch 1 right there. So we're looking at these two devices right here, basically sort of the bottom left corner. Issue the command on S1 to display the current port security status. Okay, so I'm going to connect into S1, make the window a little bit bigger going right to left, and click on my CLI tab. In my CLI tab, go ahead, get into privilege exec mode by typing enable. Here we can do the show space port dash security command. There is no port security shown here. Means nothing is configured. Enter interface configuration mode for the interface on F03 and set up port security. Okay, to get into the interface, first thing we have to do is go into global configuration mode. So go ahead and type in config T. Now we can go into the interface of Fast Ethernet 0. So interface space F0/3. We are now configuring it. We can go ahead and set up port security. First thing you need to do is remember to turn on port security. And so it's switch port dash security. Turns it on. Then once you turn it on, you can go ahead and configure it. What we want to do is say the device that's connected in, that's the device that's allowed to connect. That is our MAC address sticky. Command here is switch port. Make sure you spell it correctly, switch port. Then we're dealing in port security, so it's switch port, port security, MAC address, and sticky. Takes care of 1B onto 1C. Devices in in the LAN on S1 should be in VLAN 10. Display the current state of VLAN configuration. Okay, we need to get out of interface configuration mode, so type exit once. Out of global configuration mode, type exit twice. Now we can do a show VLAN brief, and it gives us a listing of our VLANs and what ports are in there. Devices in LAN 10 on S1 should be in VLAN 10. So devices in the LAN on S1 should be in VLAN 10. Display the current state. What ports are currently assigned to VLAN 10? Right here is VLAN 10. And devices that are connected to F03 and F04. So F0/3 and F0/4. PC1 should be receiving an IP address from R1. Does the PC currently have an IP address assigned? Well, we need to go in and look at its IP address. I'm going to minimize switch 1 here, open up PC1, look at the config tab, which is locked. So we have to go in and do it a different way. We're going to go into the desktop tab and then click on the IP configuration. IP configuration says we're pulling from a DHCP, but when we look at it, it's a 169.254 address. That is that automatic private IP addressing, the APIPA address. So it doesn't have one assigned to it. It generated its own. So no, it has an automatic private IP address, which is also known as our APIPA address. On to step E. Notice the G001 interface on R1, so on R1 right here, is not in the same VLAN as PC1. Change the G01 interface to be a member of VLAN 10 and set port fast on the interface. What we have to do is go on to switch 1 here and change that G01 interface, which is this interface right here, so that it matches up to the correct VLANs we have set up. So on switch 1 here. Let's go into global configuration mode first. Type in config T. Then we need to go into our interface of G01. So interface G0/1. We have to pull that into access or into VLAN 10. We do that by switch port. Switch port. Access VLAN 10. And then we want to set it up for port fast, so that way we skip through the negotiations of that. And that is done in spanning tree. Port fast. Gives us a warning about it, but that's okay. And it tells us port fast has been configured on G01, but only will have effect on that interface when in non-trunking port mode. So we got to make sure it stays in access port mode. F, reset the interface address on PC1 from the GUI or by using the command prompt and ipconfig/renew command. Okay, I'm going to minimize S1, open up PC1 again here. I'm going to go into the command prompt. I'm going to close this IP configuration app where it says ipconfig, the blue line. Click on the X on the right side, open up our command prompt app here, and typing in ipconfig, all one word, space /renew. Renews your IP address, goes through the DHCP process, the DORA, and now we actually have an IP address assigned to us. Does PC1 have an IP address? If not, recheck your steps. Test connectivity to the TFTP server. Ping should be successful. So we want to ping our TFTP server. Here's our TFTP server right here. Even gives us our IP address. So we can type in ping and then 192.168.20.254. 254 at the end. Hopefully we time out because we're doing an ARP lookup. So we should be timing out right now. First one timed out. Second one worked. Third one should work. And fourth one works. Let's go ahead and just repeat that command. Up arrow, enter. All four should work now that we've done our ARP lookup and it's in the ARP cache. We are able to ping our TFTP server. On to step G, the LAN connected to R3. This is R3. This is the LAN here. So this is the LAN connected to R3. This is where we're looking, the bottom right. Add an additional switch added to the topology. Link aggregation using EtherChannel is configured on switch 2, 3, and 4. The EtherChannel link should be set to trunk. The EtherChannel link should be set to form a channel without using negotiation protocol. Issue the command on each switch to determine if the channel is working correctly. Okay, let's go ahead. Jump on to switch 2 here. I click on switch 2. I slide this over, make it a little bit bigger, going right to left. Go into our CLI, command line interface. Type in enable to get into privilege exec mode. From here, we can do our show space ether channel summary. And it gives us our output. It says we have 2 ether channels. We have 2 port channels set up. And the first one contains fast Ethernet 1, fast Ethernet 2, and the second group has, for port channel 2, has fast Ethernet 3 and 4 part of it. That looks pretty good there. Let's go ahead and minimize switch 2. Let's look at switch 3. Bring that up, make it a little bit bigger. Go into our CLI. Enable, and then show ether channel summary. Okay, here, Cisco's operating system is not afraid to tell you when you did something wrong. I did something wrong here. It says I have invalid input detected at this little up arrow. If I look at the line above, here's the up arrow. Right in this area, I did something wrong. Looking at it, I spelled ether channel wrong. I inverted the H and the T. What I need to do is correct that. So I hit up arrow once, left arrow over, make the correction, type in my ether channel correctly, hit enter, and now here is our information. We see that we have group 1 here, and there's no ports listed. It shows that it is not working. There's no ports assigned to it. Group 3 looks like it's working. It has ports 3 and 4 listed, but there are no ports listed for our group 1. So there's an issue right there. Let's go ahead and check switch 4 quickly. Into our CLI. Look in the window. Enable show ether channel summary. And here we have Ethernet group 2, port channel group 2 with ports 1 and 2, and group 3 with port channels 3 and 4. So we did have a problem on 3. I'm going to bring that back up. CLI. Oh, wrong device. Switch 3 is what we're looking at. I'm just going to repeat that command, and it's showing us here that we have a code of S. S is a layer 2 for a switch, and then we have a D. It's showing that we are down. It's showing that port channel 1 is down. Our problem here is S3 shows port channel 1 as down, or a capital D. Modify switch 3 to include ports fast Ethernet 1 and 2 as port channel 1. To do that, we can use the interface range command, because we have to do it to fast Ethernet 1 and 2. Go
But first we need to go into global configuration mode. So type in config T. Now we can go ahead and go into that range of interfaces. So it's interface, range, and then fast Ethernet 0/1. Then you got to make sure you put your space, dash, space, and then the ending number, which is 2. You don't put fast Ethernet 0/2 in there. You just put the number 2, so that gives you a range. If you see your prompt, you can see that you're in the configuration mode of an interface, but it's a range of interfaces. So any command you do right now will apply to this range of IP addresses. And what we need to do is assign it to channel-group 1, and then we need to set the mode to on with no negotiation. As soon as I hit enter, we got some system updates. It says link state changed. We went to up. Our line protocol has now went to up. Verify the trunk status on all switches. We do that from global configuration mode, where we have to type exit once, exit twice. Now we can go ahead and type in show interface trunk. And we can see that we have our port group 1 is on and that we are trunking. If we go back and do the show EtherChannel summary, if I would spell EtherChannel right, we can now see that our port channel 1 is an S for switch and U for in use or up. And so we are up and running. Were there any issues with trunking when we entered in the show interface trunk? I'm going to re-enter that command. Up arrow twice or 3 times. There's the command. We have no underneath status. There are no issues. So everything is working good. But we need to go and look at all the switches. So that was switch 3, minimize it. Go ahead, look at switch 4, enter in our show interface trunk command, which just gives us all the interfaces that are trunks. We're looking pretty good here. Doesn't show us we have any problems. And we need to go and verify switch 2. Switch or show interface trunk. Looks like we are doing good, except for, oh, we have a VLAN mismatch, I think, right here. Gig 01. So here on switch 2, VLAN 1 is the native VLAN where we've been using 99 on all the other ones. We do have a problem there. So S2 is using VLAN 1 as the native VLAN on the link of G 0/1 interface. Correct the trunk issue on S2. Now we need to go in and correct the VLAN, the native VLAN on S2. We do that from global configuration mode. So go ahead and type in config T. Then we need to go into the interface of where we are having that problem. That was G01. So interface G0/1. And now we need to set the native VLAN. That's all part of the switch port functionality. And trunk native VLAN 99. That'll set up all native VLAN 99, so any untagged traffic will be put into VLAN 99. Was correcting the issue. On the K, spanning tree should be set to PVST plus on switch 2, 3, and 4. S2 should be configured to be the root bridge for all VLANs. Issue the command to display spanning tree status on S2. We do that from privileged exec mode. Type exit once, exit twice. Now we're in privileged exec mode. It is show spanning dash tree, show spanning dash tree summary totals. Here it's saying which is in PVST mode. It's also showing us it's a root bridge for, and then there's nothing listed. So there is no root bridge here. What we have to do is we have to go ahead and change that. Now to change that, we go into global configuration mode, config T. From here, we need to do that using spanning tree summary. Nope, not spanning tree summary, but spanning tree VLAN 1 to 1005. And for all those VLANs, we're going to say this is the root primary. Okay, I hit enter. It takes a couple seconds to go ahead and do that. We are waiting for it to respond, and it came back. It does take a little bit because it had to go through all 1005 VLANs to set that up. If we go ahead and issue that show spanning tree summary totals again, type exit once to get into privilege exec mode, and then show spanning tree summary totals, we can see that we're in PVST mode, which we want, and then it's a root bridge for the default VLAN 30, VLAN 40, VLAN 50, and the native VLANs. That's what we're looking for. That takes care of part 1. On to part 2, verified DHCP. R1 is the DHCP server for the R1 LAN. Here is R1. And this is the R1 LAN, the LAN that's connected to R1. R3 is the DHCP server for all 3 LANs attached to R3. So R3, right here, is a DHCP server for all 3 LANs attached to R3. Now, how do we get 3 LANs? If we look here, PC4 is in one VLAN, PC3 is in another VLAN, PC2 is in another VLAN. These are 3 separate LANs. They're virtual LANs, but they're still LANs, and the DHCP server for all 3 of those VLANs is R3 right here. It's R3. Check the addressing of the PCs. Do they all have the correct IP addressing? Let's go ahead and look here. I clicked on PC2. Go into my desktop tab, and I'm going to click on IP configuration. IP configuration says we have an IP address of 192.168.30.10 with a subnet mask of a /24 and our default gateway. What I'm going to do is I'm going to go over here into Word, and underneath the View tab, I'm going to say I'm going to split my screen. What that's going to allow me to do here is see my question in the bottom split, but in the top split, I'm going to go up to my addressing table. That'll allow me to see the addressing table, see if that information is correct. PC2 is what we're on. It's assigned by your DHCP server, so that looks pretty good. But we are looking here. The IP address is on the same network as our default gateway. We are looking all pretty good at that. I'm going to go ahead and minimize PC2, PC3. Once again, I'm going to click on the desktop tab, click on the IP configuration app. Looking at this, we have an IP address 192.168.40.10/24 of our address. Default gateway 192.168.30.1. Subnet mask says the first 3 octets are the network portion. Network portion needs to be the same between IP address and default gateway. If we look, 192, 192, 168, 168, and the third octet, .40.30. Default gateway on PC3 is wrong. Oh, we're going to have to go in there and correct that. Let's go ahead and look at PC4 quickly. Click on PC4, come over here, look at my desktop tab, look at my configuration. Here we have 192.168.50.10 with the /24 and a default gateway 192.168.30.1. Uh-oh. Subnet mask says network portions first 3 octets. If we look at our third octet again, IP address is .50, default gateway is a .30. Those should be the same. Default gateway should be a .50.1 to be on different networks. We're going to have to go in there and figure that out. But to answer our question, no. PC3 and PC4 have incorrect default gateways. Check the DHCP settings on R3. Filter the output from the show run command starting with the DHCP configuration. So we're going to go back to R3 here. Looking here, type in enable, brings us into privilege exec mode. Then we're going to do a show run here. Do a show run. And then we're going to filter where we begin with the first instance of DHCP. So where it first says DHCP, we're gonna start displaying that. Hit enter, and here's our information. I know it says more there, but I'm just gonna hit Control C at this point in time. We can see our information. We're excluding some addresses from the .30 network, from the .40 network, and from the .50 network. Here's our DHCP pool for our LAN 30. It says this is the network we're handing out. Once again, we do have some exclusions for those networks we stated above. And our default router is 192.168.30.10. Looking at our network portion, that's the same between our network address, the first 3 octets, and our first 3 octets on our default gateway. Here's the IP address for VLAN 40. We're using the network of 192.168.40 with a /24, so our first 3 octets. Here's our default router. And right there is our problem. The third octet here is incorrect. It should be a .40. Should be handing out a .40. And down here for our VLAN 50, we also have the same problem. The default gateway is specified incorrectly. Question, are there any issues with the DHCP configuration? Yep, the default router we're handing out has the wrong IP address. So we need to go in there and fix this. Our answer is the default router setting is incorrect on LAN 40 and LAN 50. And let's put the correct name in there, LAN 50. Make any necessary corrections and reset the IP addresses on the PC. Check connectivity to all devices. Were you able to ping all IP version 4 addresses? Okay. So let's go ahead and make the correction. We need to go in and change those settings. To do that, what we have to do is go into global configuration mode, config T. Then we need to go into each one of those pools. So IP, DHCP, pool, LAN 40. That had one incorrect IP address. So we have to do a no network. Actually, the network was correct. We have to do a no default router with the wrong IP address, 192.168.30.1. I hit enter, so remove it. Now we can go ahead and do the right one. We can say default dash router 192.168.40.1 because we're on LAN 40. That sets it correctly. Exit out here because that took care of that. Now we have to go back into IP DHCP pool LAN 50. Remove the wrong one, so no default dash router. And the wrong IP address here, once again, for our default router on LAN 50 was 192.168.30.1, 192.168.30.1. We can go ahead and put the correct one in there. And that's default dash router default router 192.168. And we're on VLAN 50, so 50.1. Exit out, exit out. Looking good. We have to verify, reset the IP addresses on our devices. PC2 was working good. It had the correct default gateway. I'm going to minimize that. Go to PC3 to reset it. We can either do the IP config renew from the command prompt, which we'll do right here. So where it says IP configuration on the blue line, click on the X, open up our command prompt, type in IP config space / renew. Should come back. We got our IP address 192.168.40.10 with our default gateway that's on the same network. Our third octet is 40. That's looking good. Let's go ahead and fix PC4 right away. Close out my IP configuration app, open up my command prompt, IP config / renew. Give it a second to do the DORA process. Here's our IP address, .50.12. Yours might be a little bit different, but it should be close. But your default gateway should now say 192.168.50.1. So now our default gateway is on the same network as our IP address. That is looking good. Check connectivity to all devices. What we'll do is, let's go ahead. I'm going to minimize this. Go to PC2, close my IP configuration window, open up my command prompt, and I'm going to ping PC4. So ping 192.168.40. What was it, 10? I'm going to click on PC3 here. Its IP address was 40.10. So back on PC2, so 40.10. Should work. Maybe we're timing out on the first one because we're doing an ARP lookup. There we go. Those three worked. I'm going to repeat it again. Up arrow, enter. Make sure all four successfully worked. Now let's go ahead and ping PC4. So ping. I'm going to click on PC4 here to bring up that number. Its IP address was 192.168.50.12. Back on PC2, I can go ahead and ping that 192.168.50.12. Your IP addresses may be a little bit different, so make sure you're using the right ones instead of following me exactly if it's not working. Had an ARP lookup probably for the first one. I'm just going to repeat that command, up arrow, enter. All four pings are working. Okay. Now the question would be, we can ping internally, can we ping outside? Let's go ahead and try and ping our outside host, 64.100.100.10. So from PC2, ping 64.100.100.10. Destination unreachable. 192.168.30.1 is saying it's unreachable. Well, that's my default gateway. My default gateway here is on R3, saying I can't reach it. I don't know how. It does not have a route there. Okay, let's try pinging PC1. So we can type in ping, and then the IP address here, PC1. If I click on PC1, I can go ahead and type in IP config here on PC1, get our IP address. Our IP address is 192.168.10.10. Let's try pinging that, 192.168.10.10. And we're able to ping that one. So we're able to ping from PC2, keeping it all internally, to PC1. Let's try pinging our TFTP server. Ping, and we can get the address right there on the topology, 192.168.20.254. And we're able to do that. So we're able to ping all internal addresses, but we were not able to ping our outside host. Okay. All PCs were able to ping internal hosts, but were not able to ping external hosts. On to part 3, verify routing. All routers are configured with OSPF process ID 1, and no routing updates should be sent across interfaces that don't have routers connected. Looking here at router 1, so it has OSPF configured with process ID 1. Updates should go out these two WAN interfaces because they're connected to R2 and R3. R2 and R3 can use OSPF, but going out this LAN interface, gig 001, we shouldn't send OSPF updates out there. So this should be a passive interface going to these, because none of these devices here need to know or need to receive any OSPF updates. R2 is configured with an IP version 4 route pointing to the ISP. So R2 has a IP default route pointing to our ISP, pointing out, and redistributes the default route in the OSP version 2 domain. So we will distribute that default route to these other two routers down there, R1 and R3. R2 is configured with the default IPv6 fully qualified default route pointing to the ISP2. So we have done that for IP version 6 pointing to the outside of our network, to the ISP, and redistributes the default route in OSPF version 3 domain. NAT is configured on R2, and no untranslated addresses are permitted to cross to the internet. So no untranslated addresses. A, check the routing tables on all routers. Okay, so we can go onto the routers. We'll look at R1 first. And on R1, we log in, get into privilege exec mode. From here, we can do show IP route and only show the OSPF information. So show IP route OSPF gives us our information. These are the routes we have learned about through OSPF. There are several of those. Okay, that's looking good. Let's go ahead and look at R2. Bring that up, make it a little bit wider on my CLI tab. Log in, type in enable, privilege exec mode. Here we do show IP route and only the OSPF information. We are looking, we have learned different routes, different networks. That's looking pretty good. And let's go ahead and look at router 3. Enable show IP route OSPF. And we're looking and we can see that information. Okay, that looks pretty good. But there was one other thing we were setting up here. We were setting up here the default routes and to propagate them through OSPF version 2 and OSPF version 3. We need to go in and look and verify that. So I'm going to go into R1. Instead of just only showing the OSPF information, let's go ahead and show IP route. Gateway of last resort is not set. Oh, R1 doesn't have any information there. Let's go ahead and check R2. Once again, show IP route. It has the gateway of last resort here. So that's set. It even shows us down here, it's statically. It gives us the asterisk here saying this is the candidate for the default route. It's directly connected. So we're sending all that information out, gig 003. Let's go ahead and check R3 here. That was show IP route. Show IP route default, or the gateway of last resort isn't set. There is no asterisk anywhere, so we don't have a candidate. So it doesn't look like OSPF is propagating it. Now, all the routes, they did appear, look like they were coming through OSPF, but it didn't look like there was any propagation of that default route. So all of the networks are in the routing tables. However, the default route is not propagated to R1 and R3, so there is only connectivity to the outside from R2. Ping the outside host from R2. Okay, go on to R2. In privilege exec mode, we can ping, so type in ping, and then here's the outside host. This is the IP address, 64.100.100.10. 64.100.100.10. First two failed, probably because it had to do some ARP lookup here on the ISP and inside the cloud, but the last three worked. Verify it. I'm just going to hit up arrow, hit enter to repeat that command. All five work. So R2 is able to ping to the internet. There. So was the ping successful? Yes, it was. Now we need to correct here that the OSPF is propagating that out. To do that, we have to go into R2 into the routing protocols and say, okay, we're going to send out all that default information, and this is going to be the where we're going to originate that default information from is on R2. Okay, go into R2 here. We have to go into OSPF. So from privilege exec mode, type in config T, get us into global configuration mode. From here, we need to go into our OSPF protocol. So it's router OSPF, and then our process ID was 1 again. Now we can go ahead and say default originate. No, it's not default originate. It's default dash information space originate. And I'll say, okay, propagate out all the default information to all the other OSPF devices, and this is where they're going to get that information from. Now, I spelled information wrong here. I corrected it. Now we're going to be able to propagate that out. Check the routing tables on R1 to R3. Make certain that default route is present. So I'm going to go to R1. I'm going to do the show IP route command. Now we do have the gateway of last resort pointing to 10.1.1.2, taking all traffic. So any traffic that doesn't meet any of these routes here, actually I'm going to hit spacebar. Any traffic that doesn't meet any of these routes here, we're going to take all of that traffic specified by the network of quad zero, and we're going to send it to 10.1.1.2, which is our R2. Then R2 is going to send it out to our ISP. Let's go ahead and check R3 right away. R3, we can do the show IP route command. Here on the show IP route command, here's our default gateway. And if we look down here, we can see that there's an O for the network of 000, the quad zeros. We're going to send it to this IP address. The other thing here is to see that we do have an asterisk here. That asterisk says this is the candidate for the default route. So that tells us we know about that, and we learned about it 48 seconds ago. Okay, so we did check the routing tables, make sure it was present. Test IP version 6 from R2 to the outside. The ping should be successful. Troubleshoot if they are not. So from R2, we are going to ping the IP address of the outside host, but we're going to ping the IP version 6 address. To ping, we have to be in privileged exec mode, so type exit once, exit twice. Now we can go ahead and type in ping 2001 colon db8 colon b colon 64 colon 10, and all 5 pings worked. Those pings worked great. Test IPv6 connectivity from R2 to PC4. So from R2 to PC4 down here. If the ping fails, be sure to check that IPv6 addressing matches the addressing table. Okay, so from R2, we have to ping the IPv6 address of 4, which is right here, 2001 colon db8 colon b colon 50 double colon 10, and that worked. Once again, IPv6 doesn't have to go through the ARP process, so we don't lose a ping or two because of the ARP lookup. IPv6 has a different mechanism that doesn't use that. All 6 pings should work every time right away. Okay, that took care of F. On to G. Test IPv6 connectivity from R3 to the outside host. If the ping fails, check the IPv6 routes on R3. From R3 here, we want to ping that outside server IPv6 address. Slide this over. From privileged exec mode, we can type in ping and then 2001 colon db8 colon b colon 50 double colon 10. Nope, that's not the address we're going for. We're going for this address up here. I need to go and retype that address over. So starting over from R3 to the outside, ping 2001 colon db8 colon b colon 64 double colon 10. It is failing. Once again, we don't have ARP lookup, so it shouldn't be failing. Now, what did it say? Let's go ahead, check the IPv6 routes on R3. So our success rate was 0%. Let's go ahead and check our IPv6. Now, instead of show IP route command, that'll give us IP version 6. We'll go ahead and put show IPv6 route. And that lists out all the information. And it doesn't have anything with our default route in there. We don't have anything. So our default route isn't originating at R2 or anything like that. I'm guessing R2 isn't propagating that information out. If the route does not appear, modify IPv6 OSPF configuration on R2. Let's go ahead to R2. Modify that configuration. We do that from global configuration mode. So go ahead and type in config T. From here, we have to go into the OSPF of IPv6. So we start out by IPv6 OSPF and our process ID. Oh, no, I forgot the word router. So IPv6 space router space OSPF 1. That gets us into process ID for OSPF for IPv6. Now we can go ahead and say, okay, our default information, it's going to originate here from R2. And that is default dash information. And then we're going to say it originates here from this device. And I spelled information correctly. So I hit up arrow, left arrow over, spell information correctly. And I spelled originate wrong. Now we have it propagating correctly. Check connectivity from R2 to the outside host. Well, R2 to the outside host. That worked fine before. Exit, exit. And that was when we pinged that. But what we need to do is now check on R3. So R3, what I'm going to do here is repeat the show IPv6 route command. For IPv6 OSPF version 3, this is our default route right here, pointing us out our gig 020 interface. On R3, that pushes it to R2, then R2 can use that. So we are propagating that information out. That default information is originating from R2. We can now go ahead and ping out, and we should verify that R3 can now ping our outside host. I up arrowed a couple of times to find that ping command, and now our ping works successfully now that we're propagating IPv6 default route information out of R2. On to part 4, verify WAN technologies. Serial link between R1 and R2 is used as a backup link in case of failure. Should only carry traffic if the fiber link is down. So the link between R1 and R2, this link right here, is a backup link and should only carry traffic if the fiber link is unavailable. This is a fiber link here. This is red or orange. And this here is a fiber link. If one of these two goes down, this is a backup link here. The Ethernet link between R2 and R3 is fiber. The Ethernet link between R1 and R3 is fiber and should be used to forward traffic from R1. Any traffic that should go out of R1 should use this one. In case these routes fail, this is our backup here. So we'll use that in case of an emergency. Take a close look at the routing table on R1. Okay, let's look at R1 here. R1. I'm going to issue a new show IP route command. Make sure I have the most up-to-date information. Take a close look at this. I'm going to slide this over a little bit. Here's the show IP route command. Looking here, we have our directly connected devices, but then we have our OSPF networks. Here we have network 10220, and that's going through serial 010. So to get to this network 10.2.2.0, we're going out our serial 010 interface, which was this WAN link that we were only supposed to use as a backup in emergency. So that traffic should be going out this link, the gig 000 network, so that's wrong. Then we have some more directly connected networks, more directly connected. Then we have an OSPF network, 192.168.20.0. That's this network up here. That's the top left network. In that network, we go out serial 010. That's this interface here again. That's this interface right here, but this is on the link that we're only supposed to use as a backup. We should be using our fiber network there. And so we should be using the fiber and not going across this WAN link here. Okay, so that is set up wrong. Then we know about the 192.168.30 network. The .30 network is a VLAN over here. That's going out our G00 interface. That's looking good. We know about the 192.168.40 network. That goes to PC3. That is also going across our G00 network. So that's going across our fiber connection. We know about the 192.168.50 network. That's PC4. That is also going out across our G00 network. Looks like we do have two troubles right here. The 10.2.2.0 network is going across serial 010, and the 192.168.20.0 network is going across the serial 01 network. Use traceroute to confirm that. Well, from PC1 here, we can do a traceroute to our TFTP server. Okay. Open up my PC1. Make sure I click in the window. Now I can do a trace route, and it's trace route. You spell out the whole word, no space, and then you put the IP address of your TFTP server in there, 192.168.20.254. The trace route on a PC, because we're on PC1 here, is a little bit different syntax than it is on a router. Instead of spelling out trace route with trace and then ROUTE, it's trace RT in a Windows system. And then you put in the IP address 192.168.20.254. And it shows us that we went from the PC to our default gateway, which is here. Then we went across the 10.1.1.2 network, which is here, up to this interface. So it takes us right here. So it went from R1 to R2, and then it was able to reach the TFTP server. So it went across the network we didn't want it to. We need to make that change so it does go to the TFTP server. We can also verify this by going on R1 and typing in the trace route command here. So trace route with the word route spelled all the way out, and then put in our IP address of 192.168.20.254, and we can see the same thing happened. We went from our device to the device 10.1.1.2, which is on this network, which is this IP address. So we went from R1 to R2 and then to our TFTP server. We did not use the correct network connection. We didn't use the one we did. We used the backup emergency. So we need to go ahead and configure that. Are there any routes using the serial link? Yes. Which routes are they? It's, and looking at our table here, it's the route for the 10.2.2.0/30 network, the 10.2.2.0/30 network, and the other one was our 192.168.20.0/24 network. And 192.168.20.0/24 network. Use the trace route. Notice the traffic is being sent out serial 10 interface instead of the gig interface. Yep, we got that. On to B, the original configurations that came from the previous serial WAN connections were transferred to the new device. Compare the gig 00 interface and the serial 00 interfaces. Okay, so let's go ahead and look at those interfaces. So do a show run. Go down to our gig 000 interface. Here's our gig 00 interface. And we can see that it's an SFP module. We have an IP address. Oh, here we have a special cost setting. We have a cost of $648. Notice they both have a cost, and so serial 01 also has that cost set. Notice they both have an OSPF cost value set. Remove the OSPF cost setting from the gig 00 interface. It'll be necessary to remove the setting on the link on R3 that connects to R1. So we have to go into R1 and R3. Currently we're in R1. I'm going to hit Control C. What we have to do is go into global configuration mode, config T, go into that interface here. So it's interface of G0/0/0. And then to remove it, we have to type in no IP OSPF cost 648. Exit. Type you out, and then we also have to go and do that on R3 also, because we did set a cost there. How do we know that? Let's just go ahead and confirm that. Enable, do a show run. Here is our interface. We're looking for gig 010, and we do have an OSPF cost. We need to remove that also. So we go into global configuration mode. We go into the interface of gig 0/1/0, and we type in no IP OSPF cost of 648. Reissue the traceroute command from R1 to verify the path has changed. Okay. So from R1, we need to reissue that traceroute command. So type exit to get us into privileged exec mode. Then it's traceroute. And then the IP address. Oh, I got to spell traceroute correctly. Sorry. Traceroute. And then the IP address of our TFTP server, which is 192.168.20.254. This time when we did it, we went from R1 to a device on the 10.3.2 network, which is this network, which is this interface right here, which is this interface. So we went to here, then we went to a device 10.2.2.1, which is on this network right here, which happens to be this interface right here. So we went from R1 to R3 to R2 to our TFTP server. We did not go across that WAN connection. We did not go across our backup connection. Were the pings successful? Oh, sorry. The change has been made to direct traffic over the faster link. However, the backup route needs to be tested. Shut down the gig 020 interface on R3 and test the connectivity to the TFTP server and to the outside host. Were the pings successful? So we have to go into R3 and we have to shut down the gig 020 interface. So we need to go into that interface. Currently I'm in global configuration mode, so I can just go into interface G0/2/0 and type in shutdown, and that will turn that interface off. We can see that this has now went down. We now have orange or amber triangles pointing down, meaning this connection is down. So something happened. A backhoe cut a piece of fiber is probably what happened. That's what we're simulating right here. Now our backup WAN connection should take over. Ping the TFTP server. Let's go ahead and do that. We can also see that we got some system updates, that a connection did go down. We lost some adjacencies. Our neighbors went down, and we're on R3. We need to go back to R1. Let's go ahead and ping our TFTP server. Once again, our TFTP server is 192.168.20.254. And the pings are working. Let's go ahead and do a trace route here to 192.168.20.254. And once again, spell out the word trace route. And this time, we went from R1 to R2 into our device, because that's the backup connection. It should take over because we lost this fiber connection here for some reason. Were the pings successful? Yes, they were. Yes. And then for the second part here, we tested the TFTP server. Now we need to test to the outside host. Let's go ahead and ping the outside host address, which is right here, 64.100.100.10. So 64.100.100.10. Oh, these aren't successful. Or maybe it was doing an ARP lookup. Oh, failed twice. That's usually a bad sign. 3 times is even worse. 4, we're pretty much done. 5, nope. We're not able to ping it. PC1 is not able to ping the outside host now that this route is down. We did not get the backup to take over that route to the outside, the default route. That was the default route we were propagating from R2. Yes, TFTP server was able to be pinged. No outside host was not able to be pinged. R2 is required to perform NAT for all internal networks. Check the NAT translations on R2. Okay, let's go ahead and look at R2. On R2, type in config T to get us into global configuration mode. Actually, no, we type in enable. Sorry, type in enable to get into privileged exec mode. Then from here, we can do our show IP NAT statistics. Nope, translations. And there are no translations. This list is empty. Otherwise, it would list out the translations. Notice that the list is empty if you only attempted to ping from R1. There are no translations that are happening. Attempt to ping from R3 to outside host and recheck the NAT translations. Okay, so from R3, we are going to ping. So I need to exit out to privilege exec mode and then ping our outside address. Our outside address is 64.100.100.10. And our success rate also was 0. Now recheck our translations again on R1, or on R2. So go back to R2. Let's go ahead and do our show IP NAT translations. I just hit up arrow, hit enter. Still no NAT. Issue the command to display the current NAT statistics, which will also provide the interfaces involved in NAT. So the command we want to show is show IP NAT statistics. When we do the show IP NAT statistics, we can see the outside interface here is gig 00 and the inside interface is gig 01 and gig 010. G, set the serial 00 interface as an inside interface to translate addresses. What we need to do is set this serial 00 interface as an inside address also, so that it will translate those addresses for us when it goes down. Okay, on R2, to do that, we have to go into global configuration mode, so config T, and we have to go into that interface, the one where we want to set as an inside. So that was interface serial 0/0/0, and then we need to say that's an inside interface. So IP NAT inside sets that as an inside. Now we can minimize this and we can go down here and test connectivity from R1. We can go out here. We can ping that outside address. All I'm going to do is hit up arrow once, hit enter, and our pings have worked. We are able now to ping from R1 to the outside interface with this fiber connection being down. So our backup connection is working as intended. Ping should now be successful. Re-enable G020 on interface R3. Okay, so let's go back into R3 here. Go back into that interface, config T for global configuration mode. Interface of G0/2/0 and do a no shutdown on it. We can see the line shade, the interfaces went up, the line protocols went up. Okay, that takes care of part 4. On to part 5. Devices should be configured according to the addressing table. Every device should be able to ping every other device internally. The internal PC should be able to ping the outside host. PC4 should be able to ping TFTP server and outside host using IPv6. Okay, let's go ahead and see and ping every device. What we're going to do is I'm going to go on PC1 here. And I'm going to ping every device. If one ping goes to PC2 and it comes back, I can verify that PC1 can talk to PC2. I'm going to then ping PC3. If that ping works, I'm going to also assume that PC2 to PC3 works. So I'm just going to go ahead and ping every device, every server using IPv version 4 addresses. So here's PC1. First thing we want to do is ping PC2. I'm going to pull up PC2's information. IP config gets us that IP address 192.168.30.10. 192.168.30.10. PC1 to PC2 is able to be pinged. Let's go ahead and ping PC3. Minimize that, open up PC3 here. Here's our IP address. I'm just going to repeat that command. Oh, that was a renew command. IP config. Here's our IP address, 192.168.40.10. I'm going to go ahead and ping that address, 92.168.40.10. That's pinging PC3. That looks like it successfully works. Now we're going to go ahead and ping PC4. So ping, click on PC4, type in IP config. Make sure we're getting current IP addressing information. Here we have 192.168.50.12. Go ahead and ping that address, 192.168.50.12. You may get different IP addresses depending upon how DHCP handed them out, so make sure you look them up. If the address I'm using and you use on your network isn't working, make sure you do the IP config on the device you're trying to connect or ping to. So that was PC 2, 3, and 4 I'm able to ping to. Let's go ahead and ping our TFTP server. So that is ping 192.168.20.254. I'm able to ping my TFTP server, and the last thing we have to do is ping our outside host. So ping 64.100.100.10. IPv version 4, all able to ping each other, and I'm assuming because they all can ping PC1, I'm assuming they can all ping each other. And PC4 should be able to ping TFTP server and outside host using IP version 6. So I'm going to go ahead, open up PC4 here, and type in ping, and then put the IPv6 address of the TFTP server. So 2001:B:20:254. We are able to ping our TFTP server. Once again, notice there is no ARP lookup because IPv6 does not have to have that ARP process when they do ICMP commands. And the last thing we need to do here is ping the IPv6 address of our outside host, which is right here. So that gives us 2001:B:64:10. We are able to successfully ping the outside host using the IPv6 address. That was Packet Tracer Lab 12.5.13 Troubleshoot Enterprise Networks. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.